So good day everyone. Today we are going to discuss how amplifier behaves at low frequencies. So when we are going to look at this circuit, we see three critical capacitors. So first is the input coupling capacitor, which is the C sub S. Second is the output coupling capacitor, which is the C sub C. Next is the emitter bypass capacitor, which is the C sub E. So in midband frequency analysis, we usually treat these as short circuits, but at low frequency, their capacitive reactance increases significantly. So each of these mga capacitors forms a high-pass network with the surrounding resistors, establishing its own kanang lower cut-off frequency. So ang ato ang goal today is to find the cut-off frequency for each capacitor and determine which one dictates the overall lower frequency limit of our system. So now, let us move to our first formula of the input system. So we have F sub Ls is equal to 1 over 2 pi times R sub I times C sub S. So as we are going to look at this formula, it determines the cutoff frequency due to C sub S. So the K here is finding the total AC resistance R sub I looking into the base. So for this voltage divider configuration, R sub I is parallel combination of the biasing resistor R sub 1 and R sub 2. So ang R sub 1 and R sub 2 is parallel na silang duha. So if you are going to solve it within a parallel formula, kaya naman na siya own formula ang pag-solve sa parallel, whether it is parallel or whether it is a series combination. So we will have an answer of R sub I. So it depends po kung sa mga variable ang mga gamiton. But here sa atoan na sa circuit, they've used R sub I. So, and an internal dynamic resistance of the resistor reflected to the base, which is the beta R sub E, which is R sub E is small, as you can see on the screen. So now let's move forward to the output side, which is the coupling capacitor or the C sub C. So here in the C sub C, we have F sub LC is equal to 1 over 2 pi times R sub O plus R sub L times C sub C. So as you can see on the formula, it is seen by the output capacitor is the series sum of the amplifier's output impedance R sub O and the load resistor R sub L. So diba sa first formula is ang R sub 1 and the R sub 2 is parallel. Here in this second formula, naka-series na ang R sub O o R sub L. Okay, it depends on the circuits, pero another is ang sa output is series na siya. So since R sub O is simply ang R sub C ra siya in parallel with the transistor's internal output resistance, we find our total loop resistance to compute the output cutoff. So muna siya ihang formula. Next is we have the emitter bypass capacitor or the C sub E. So the formula for it is same siya sa first formula, pero lahi nga mga values ang mga ginabutang. So we have F sub LE equals 1 over 2 pi times R sub E times C sub E. See, this formula often the trickiest one kuno sa two formulas nga gina-mention, because the resistance R sub E nga na diha is the combination of the emitter resistance in parallel with whatever is looking back up into the emitter terminal. So it depends daw. So that internal resistance is plus to the base network resistance, which is ang base network resistance is parallel, which is ang R sub 1 o R sub 2. Ma-divide na siya sa ato nga beta to reflect it down sa the entire nga emitter side. So now kay na-mention na naman nato ang atuang mga formulas nga may use sa atuang frequency, let us have our first example. So, before we are going to calculate any cutoff frequencies nga ito nga gina-mention, we must perform first our DC analysis to find the transistor's dynamic resistance. So, first, we verify if we can use the approximate method by checking. Kay dapat man siya i-verify first, kay dapat i-analyze din siya if pwede ba. So, our beta R sub E is greater or equal to the 10 R sub 2. So, substituting our values, which is ang ato ang akuan is 100 times 2 kilo ohm, which is equal to 200 kilo ohm. So, which is much greater than kaysa sa 10 times 10 kilo ohm, which is na sa screen, which is mo equal siya og 100 kilo ohm. So, the condition is satisfied. So, using the voltage divider rule, the base voltage is approximately 4V. So, atong V sub B is 4 volts. And subtracting the 0.7 base to emitter drops gives us an emitter voltage V sub E of 3.3 volts. So, if you're going to minasan na to ang V minus 0.7, maka-create ta og volts nga 3.3. So, dividing this by R sub E gives an emitter current which is 1.65 millimeter ampere, because if we are going to divide the R over V, we will get a current. And now, since na-calculate na ta sa ato ang current, ato na po na siyang i-substitute para makaget ta sa given formula, which is V small r sub E equals 26 millivolts over 1.65 milliampere. So, makaget ta og 15.76 ohms. So, multiplying by beta o our input base resistance is beta times R sub E is 576 kilo ohm, since na may value daan ang beta nga gina-mention diha. So, calculating the individual cutoff frequencies na ta. So, we are going to solve these frequencies depends on the formulas that they have been mentioned. So, first, we are going to calculate the input, which is the C sub S. So, we calculate R sub I by using the parallel, which is the R sub 1 parallel to R sub 2. Okay, di ba ang pag-solve anang R sub 1 R sub 2 is imo na siyang i-times ang R sub 1 ang R sub 2 beta R sub E, and after pag times imo na siyang i-divide by summation sa tulo, so which gives 1.32 kilo ohm. So, plugging this and C sub S is equal to 10 micro F into our formula, maka-yield ta or maka-create ta og hertz, which is 12.06. So, after makaget na ka atong R sub I nimo, so imo na siyang i-plug atong 1 over 2 pi C sub S and also the R, so maka-create tag 12.06 Hz. So, next is for the output FLC, which is the C sub C. So, since ang atuang small R sub O is infinite, so ang atuang R sub O is just R sub C. So, same na siya, equal na siya, which is 4 kilo ohm. So, adding the R sub L, which is 2.2 kilo ohm, gives a total resistance of 6.2 kilo ohm. Kaya diba ang nasa formula is 1 over 2 pi, tapos naka-series na ang R sub O o R sub L. But since ang R sub O is R sub C, so 4 plus 6.2 equals kilo ohm, with ang C sub C nga 1 microfarads, we could get 25.68 Hz if you are going to calculate it within the given formula. So, muna siya nga answer nga ato nga maget. Next is the for the emitter. So, reflecting the base network down, our resistance calculates to 91.38 ohm. Plugging this in with CE or C sub E, the 20 microfarads give us 87.13 Hz. So, Same na Japon sa mga methods or solutions sa other formulas, mo na siya ato ang ngayon i-substitute ito ng mga values nga naa na diha. Mo na makaget ta og 87.13 Hz. So, since we are done with the solution, we are done with one example now. Let us determine the dominant frequency. So now we have the three values. We are need to determine the true lower limit of the amplifier. So dili pa dahil itong tulo ka buok ang iya nga true limit kinapagoy mas nga gina find pa nga true value. So remember the core rule. So when moving from higher to lower frequencies, the highest calculated cutoff frequency is always the dominant one. So it is the first obstacle or boundary. So the signal hits as frequency drops, causing our system gain to plummet. So let's look at the two methods to finalize our system cutoff. So they have a method pala. So it is not only one but two methods. So first is by inspection. So here in by inspection, we are going to compute, or we are going to compare the three answers that is given on the example. So we have 87.13, 25.68, and 12.06 Hz. So if you're going to compare it, so asa mas ko, what is the greatest? So we observe that the C sub E dominates. So ang answer sa ato nga dominate is the 87.30 Hz if we are going to use the inspection method. But in the calculation method, it is more likely not on the comparing but on mathematical square root approximation formula. So there is actually a formula and we're going to calculate the dominant one. So we have a square root of f squared L sub S plus f squared L sub C plus f squared L sub E. So if we're going to calculate this all, putting all the numbers, substitute it, we will get 91.63 Hertz. And that is the actual system cutoff is slightly higher than sa katong 87.13 Hz nga sa C sub E. So, we found by inspection. So, this kaning happens because ang duha nga other capacitor, which is the C sub S and the C sub C, exert a minor loading effect. So, munang naka-create siya mas higher or mas greater nga dominant one. So, pulling the overall kanang overall cutoff frequency a bit higher. So to wrap up, if you need a quick answer, look for the highest individual frequency. If you need an exact circuit performance, calculate the interaction using the root square formula. So ikaw rin mo choose kung sa imong nga i-choose a method, but it's up to you, or it is up on what the instructor wanted to see or wanted to have. And yeah, imora guna. So that is all the discussion all about, and